Hello friends, today I'll discuss about the one of the combination circuit component that is multiplexer. Last class I discussed about the two combinational circuits. One is the adder and other is the subtractor. Okay, so today I'll discuss about the multiplexer. So it is a one kind of the combinational circuit. So first going to discuss about the working principle of the multiplexer. First I will tell where we can use the multiplexer. All the digital components, all the combinational circuits. Okay, so we can use for different practical applications, right? So adder and subtractor. Where we can use adder and subtractor, we can use for the calculator. If you see the digital calculator, or in computer if you see the calculator, in calculator we can use the adder circuit and the subtractor circuit, right? Now multiplexer where you can use, right? So in nowadays, earlier so many applications were there where the analog components and analog systems were there. Right now in any applications you can see digital systems are available, right? So in digital systems we need a multiplexer. And where, so in communication system, right, if you want to send, if you, all of you have seen the mobile, right? So mobile, if you talk in mobile, so this is the information, your voice information, that will be sent to the other side of the other. If you're talking to other persons, that will send to the other persons, right? So that means that from mobile, the whatever information you are sending, that is transmitting through the transmitter. Huh. So in transmitter, normally multiplexer we use, right? So suppose if so many from the mobile, so many mobiles are there nearby. So for so many informations are coming. So sometimes the multiplexer, what is the function is that so many information. So it is connected to the many inputs, okay, and that is transferred to the single input, right? So during the transmission, suppose in transmission we will use the one channel, right? In we will use the one channel. So at a time only one information will be transferred from transmitter to receiver, rather using the multiple channel in communication system. Okay, information that will connect many information, many channels will be connected with the transmitter. But when you send that information from transmitter to receiver, the communication channel, so in communication channel we will use the one channel, because if we use the multiple channels at the same time, if we send the information through the multiple channel, there will have interference effect. And it will be more expensive if we use the more number of the wires, communication channels, right? So for sending I can send multiple inputs through the multiplexer, but at a time only one input will be transferred through the communication channel at the receiver, right? So here, this is the structure of the multiplexer. So many inputs, many informations are coming into the transmitter, one, two, three, four, like this way. But only one information will transfer at the output of the transmitter. So it will connect here. So if this transmitter side, the multiplexer will be there. We can represent as a mask, and here it will be the demask. Demask I will tell later, right? Here many inputs are available. Okay, this is the communication channel. Here is the output of the multiplexer, here is the input of the demultiplexer, right? So what we can say, if we see the overall diagram, if we see from the top point of view, so now we can see this, there is a switch. Okay, if switch is connected to this channel, that means this information will be transferred at the output. If switch is connected to this channel, this information will be passed into the output. If switch is connected to this channel, this information will pass into the output. In this way, by using the switch, you can control the input, which input will be passed at the output, and which input will be passed through the communication channel at the receiver side. Okay. Now, this I told that there will be one switch, whether the switch will be acting as a control circuit, and this switch will connect according to our application, which input you want to send. So switch will be connected with particular input, right? So in digital electronic system, how we'll design that kind of the multiplexer, right? So it is clear, right? So where we can use in communication channel, we can use the multiplexer where we have to send the multiple inputs, but we are not going to send the multiple inputs at the same time. At a different time we can use send the multiple inputs through the multiplexer at the receiver, right? So it has multiplexer has the many inputs and one output. Okay. Now coming to the structure of the multiplexer. Okay, so that means first I will tell here. So here will be number of select lines and select lines. Okay, here is the number of inputs. Okay, and input lines. Right. So here, how is the relationship between the input and the select lines? Okay. Now you can see in multiplex will be designed like this. Suppose you want to design 4:1. So it will have the 4 inputs. So your M will be 4. Okay. Your that output is 1. Output is not N. Okay. Output is 1. And how will calculate from the M? Right. So N is equal to, sorry, M is equal to 2 to the power n. Okay. Number of inputs is equal to 2 to the power number of select line, or number of select line is equal to log m base 2. Okay. So this that is the relationship between number of select lines and the number of inputs. Okay. So these select lines are acting as a switch. What I told that there will be a switch to control the input lines, right? These select lines will be acted as a control line. Okay. By based on the whatever input we are sending through the select line, whatever information I am sending through the select line, based on the select line, the input line will be selected. Okay. So which input line will be passed at a particular time? Which information will be passed? So there are suppose the 4 informations are passing through this 4 channel, input channel. Okay, at this one time, which information will pass at the output? That depends on the number select lines, right? So if you want to design the 4 select lines, so if m is equal to 4, n is equal to m is equal to 2 to the n, or n is equal to log m base 2, right? So here you can calculate your n is equal to 2, right? Number of select lines at 2, right? I hope it is clear, all of you. So this is the relationship between select lines and the number of inputs. Now I am coming to the types of the multiplexer. So first one is the 2:1 multiplexer. Okay, next is the 4:1 multiplexer, 16:1 multiplexer, 8:1 multiplexer, 32:1 multiplexer. So we'll discuss about the basic structure of the multiplexer. We'll discuss for 2:1 and 4:1. 8:1 is complex again. The 16:1 also again complex, and 32:1 is also complex. So if you know the structure of the 2:1 and 4:1, you can easily design the 8:1 multiplexer or 16:1 and 32:1 multiplexer. So how can you design the 2:1 multiplexer? That I am discussing now, right? So 2:1 multiplexer. In 2:1, from the name you can see that there will be the 2 inputs, right? So one is I0 and one is the I1, right? So there will be one output. How many select lines are there? So if m is equal to 2, what will be the n? N is equal to log 2 base 2. So your n is equal to 1. So number of select line is 1. That you can represent as a S. Okay. Now I'm writing the truth table. This is the structure. Okay. So first I'll write the truth table. What is the truth table for multiplexer? What our requirement? Based on our requirement, I will write the truth table. So from the truth table, I'll write the logical expression, and from the logical expression, I can write the I can design the multiplexer. This is the block diagram of the multiplexer. So what I am telling, if the this select line controls the entire thing. So based on that, you should give some logical instruction to the multiplexer, okay, or logical diagram, right? So what will be the logical diagram inside the multiplexer, right? So based on our requirement, I am writing the first truth table. What is the requirement? What is the function of the multiplexer? So based on that function, I will write the truth table. Okay. So here select line, input lines, okay, output. Okay. So if there is a one select line, right? If one inputs are there, one variables is there. So how many combinations we can write? We can write 2 combinations, right? So either S is 0. If S is 0, so I have I naught, and in output I will get I naught information. If my S is 1, so this is not required. You can write only the S and Y. Okay, you know what are my inputs. You know that I0 and I1 my inputs, right? When my S is 0, At y, this is your y, at y you will get I naught. When your s is 1, at y you will get I1, right? So from here I am writing the truth table. Okay, what is your y? Truth table means logical expression means the relationship between the output and the input. Okay, so s is 0, right? So in suppose if we see this thing, so you want to write the relationship. Okay, how can you write? So you will write these combinations. Okay, what is this combination? My output is 1. So 1 means you can write A and B. Here 1 means it is 1 only, A, B into 1. In this way we are writing. Okay, output is 1, this is multiplying. Now here, so here S is 0. S0 means my S prime. Okay, this will be multiplied with the I now. Okay, here my S is 1. S1 means here I will write S. Okay, whatever information is there, suppose it is 0, that means it will be S prime. Here it is not 0 and not 1. That's why I have to multiply I naught. Okay, now here S is 1. 1 means you have to write S. And here it is also I1. I have to write. Whatever outputs are there, that output should be multiplied with the input. But input I will not write. If 0 is there, I will write S prime. If 1 is there, I will write S. Now you can see. Now in this equation, again from equation, I will check the truth table, whether my equation is right or not. So if your S is 0, right? S is 0, that means this S prime will be 1. 1 into I naught. Here it will be 0, right? Plus 0. That means when your S is 0 and y I am getting I naught. When your S is 1, right? So the S is 1 means this will be 0. 0 into I naught plus 1 into I1. That means when your S is 1, I am getting I1 at I1 at Y naught. Okay. So this is the truth table. This is the logical expression. So from the logical expression, I will draw the circuit diagram. That entire circuit diagram will be placed into the this multiplexer. Okay. So I have S naught and I have S and S prime. Okay, S and this will be your S prime. So I naught is coming. I1 is also coming. Right? And the operation between first S prime and I naught. Okay. Then and the operation between S and then I1. After that OR operation. This is your Y naught. So these entire structures are there inside the 2:1 multiplexer. 2 AND gates, 1 NOT gate and 1 OR gate. Right? Next coming to the 4:1 multiplexer. Okay. Next is the 4:1 multiplexer. 4:1 multiplexer. In 4:1, how many select line? How many inputs? 4 inputs are there. I naught, I1, I2, and I3. Okay. And from the relationship, I can calculate if m is equal to 4, n will be log 4 by 2. It will be 2 only. You select line 2. S1, S0. Okay. So S1, S0 I can represent. Now here it is your Y. What is the truth table? Now I am writing. So in select lines S1 and S0. If 2 select lines are there, how many combinations I can write? 4 combinations I can write. Now here is Y. Now when your S is equal, both are 0, 0, first I naught will be selected at the output. Okay. Here it is I naught. In this way, if 0, 1, I1, if 1, 0, I2 is I3. Right? So what is the expression here? So S1 prime, S0 prime, I0 plus S1 prime, S0 I1 plus S1, S0 prime, I2 plus S1, S0 I3. Okay, this is the expression, right? So from this expression you can draw the logical diagram that I am not drawing. This is a little bit complex logical diagram. So the entire logical diagram will be there inside the 4:1 multiplexer. So for this logical, how many gates are there? You can see for getting the S1 prime, S0 prime, 2 NOT gates are required. 2 NOT gates. Okay. So After that, you have to do the three input AND gates. Okay, four three input AND gates. Three input, four, three input AND gates. Okay. Now again, one three input or gate is required. Two input NAND gates, two input NAND gates, four three input AND gates, and one three input OR gates. These are required to design this one. But if you know the if you once you design the 2:1 by using the 2:1, you can design the 4:1 multiplexer, right? How can you design? Okay, how can you design? Okay, so here. So what is the question? Design 4:1 mask using 2:1. Okay. So from here, how many multiplexers are required? That I will calculate from here. So which your destination multiplexer is 4:1. Your source multiplexer is 2:1. So I will divide 4 by 2 first. What is your result? 2. Okay. So these first two number of marks are required. But not till now I need one more marks. Again I will divide these 2 by again 2. Whatever results you are getting, this result again is divided by these 2. Okay, 2 is your basic marks. What is the result? 1. So 1 number of mask, 2 is to 1 mask. 1 you cannot be divided by again 2. So that is the last one. So 2 plus 1, 3 total 2:1 marks are equal. Why total? Because I am getting this 2 by dividing 4:1 by 2:1. Okay, I am getting this one when I am dividing these results by 2:1 marks. Right? So total 3 2:1 marks are required. So first I got 2, right? So I am placing these 2 here. After that I got 1 I am placing in the right hand side. Okay, right? So how many in 4:1, how many inputs are there? 2 inputs are there. And in 2:1, all are the 2:1. Okay, see? In 2:1, how many inputs are there? 2 inputs. So I am writing 2 inputs. Okay, that means these two will be like I0 and I1. These two will be like I2 and I3. And this output will going into this one and this output will be going into this one. Here I am getting final output. Okay, this is not the final structure. Okay, I have to write select line. So there are the two select lines. Where I will put S1 and where I will put S0. Normally, if you want to see, okay, I'm just checking. Okay, from the truth table I will check. Suppose if my this is 0, okay, if my this select line is 0, so from there this will be selected. Okay, so that means if this is selected, so these two output will come, two input will come here when this multiplexer, this select line is 0. This is selected means, so this is associated with the I0 and I1. Okay, so from truth table I am checking. If my S1, where is my 0? If my both are 0, 0, then I0 and I, when I0 and I0 will come from the upper section. If this one is 0, 0, so I am checking here. So these two are 0, 0. Okay, so I am just checking. If I put S1 here, now I am putting S0 here. Okay, so I am just checking. So if it is 0, right? 0. So this will be selected. Okay, for getting I0. Okay, again S0 will be 0. S0 will be 0, right? So this 0, 0, then I0 I am getting. If my S0 is 1, S0 is 1, right? S0 is 1 means, and this is also already 0. S0 is 1 means, then this I1 will be selected. Okay, got it? So here I am checking. So now if S1 is 1, right? S1 is 1. If S1 is 1, so this will be selected. Okay? If S1 is 1, this will be selected. Now, so that means now I am putting 0. If I put 0 here, okay? If I put 0 here, I3 is selected. Okay? That means this is 1, this is 0. That means this will be S1 and this will be 0. Right? So I3 is selected. That means here I will put S1, here I will put S0. MSB I am putting here, LSB I am putting here. Okay, got it? This is I hope clear. Okay, LSB side I'll put here, MSB side, and from here you can see, you can remember that MSB side, S note is LSB. LSB I'll put left hand side, and MSB I'll put right hand side. Okay, this way I can design 4:1 marks using 2:1 marks. I hope it is clear. Okay, you can also remember, see, so for getting I naught and I1, this select line will be 0. From the truth table I can see when I will get I naught and I1, when my S1 is 0. That's why I am putting S1 here. Okay. Mhm. Now I will discuss, suppose 8:1 using only 2:1 or using 4:1. Okay, so first I am drawing the 8:1. So how many select lines are there? 8 select lines are there. Okay, I naught to I7. So here it will be S2, S1, S0, 3 select lines, because if your M is equal to 8, N is equal to log 8 by 2. So it will be 3 only. This is your output Y. Okay, now I want to design 8:1 using 2:1. So I am dividing 8 by 2. Okay, same process, 8 by 2, 4. Okay, again I will show 4 number, first step 4 number of 2:1 mask, right? Again I am dividing 4 by 2, 2. Next stage 2 number of 2:1 mask. Next again I am dividing 2 by 2, 1. So 1 number of 2:1 mask. 4 to 1. Okay. Total 7 marks are required. 4 to 1. Okay. 4. Here I am putting 2. 2 lines, right? In 2:1, 1 marks are there. Okay. 2 line putting here. So I naught, I1, I2, I3, I4, I5, I6, I7. So these two will come here, this will come here. Okay. Now where we will put the S not S1 as like this we will put. Here this will be S0 in all the multiplexer. Here all these first two multiplexer all are connected to the S0. Here all are connected to the S1. Here all it is connected with the S0. How I am writing? First I will write the truth table for 8:1 multiplexer. Okay, so it will be more clear. S2, S1, S0, Y. 0 0 0 I naught, 0 0 1 I1, 0 1 0 I2, 0 1 1 I3, 1 0 0 I4, 1 0 1 I5, 1 1 0 I6, 1 1 1 I7. Okay, now you can see if my S naught is 0 0 0, which select line set what are the inputs are going to the output? I naught, I1, I2, I3. Okay, so that if your S2 is 0 0, that will be selected. Okay, right? Okay, now if it is selected that way, if you give any input here, so these 4 will be come. Okay, if you give any input, suppose if you give S, this is 0, okay, these 2 will come here. If it is 1, these 2 will come here, right? So indirectly when you give S2 is 0, the this upper portion is coming. Okay, this portion is coming here. Okay, that means here, where is my S2 here? Here. Okay, so if S2 is 0 0, these 4 are connecting. That's why I have to put S0 2 here. Okay, now if we put S2 here, S1 is 0. So this upper select line will be selected. From upper select line anyway, these 2 will come here. Okay, that means when you the value is 0 0, when I0 and I1 will come. When this value 0 0, right? That's why I'm putting S1 here, and anyway S0 will be here only. Okay, 0 0 1 I naught I1, 0 1 I2 I3, 0 1 I4, I5. Again S0, 0, 1, I6, I7. Okay, so that means LSB used to put in left hand side, MSB used to put in right hand side. Okay, now design 8 is to 1 using 4 is to 1. So for that I am dividing 8 by 4. How many? 2. That means 2 number of 4 is to 1 marks are equal. Now I cannot divide 2 by 4. It is not possible. Okay, it is not possible. Okay. Then what we to do? What is the lower marks? Then 4 is to 1. 2 is to 1 is the lower marks. So I have to divide 2 by 2. 1. That means 1 number of 2 is to 1 marks required. So here I got 2, that means 2 number of 8 divided by 4. 4 I divide, use, okay. So 2 I got. So 2 number of 4 is to 1 marks, okay. So again this 2 cannot be divided by 4. So what is the next lower mask? 2 is the next lower mask. So I am dividing 2 by 2. That means 2 I am using, okay, for dividing 2. That's the result I got. That means 1 number of 2 is to 1 marks required. First step I got 2, right? So that's why 4 is to 1 I am putting here only, and 2 is to 1 here only. Okay, so 4 inputs are there, here also 4 inputs. I know 2, I3, I4 to I5. Okay, and again you can see for getting I know to I3, this MSB will be 0, right? So that means here I have to put as 2. Okay, and then, okay, so in this way put, you have to, now is remove this one, you have to, S1 is 0, 1, 0, 0, 0, I0 should be selected. If it is 0, 1, I1 should be selected. So it will be like that. So that means S1 I will put here, S2 I will put here. Here also again, S1 I will put here, S2 put here. So if S is 0, 0, 4 select line will be, 4 inputs will be come here. Okay, that means this, where it is 0, when the 4 inputs will come, when my S2 is 0, 0, 0. Okay, so that means S2 here I put. Now if we remove this one, you can see 0, 0, 0, 1, 1, 0, 1, 1, then this 4 will be selected, okay, or at a time, right, at a one time. So 0, 0. So that means in the left hand side I will put S1 and the right hand side I will put S0. Okay, I think it is clear. So in this way, you can, by following these rules, you can design 16 to 1 mask using basic lower order mask. Also, you can design 32 to mask using basic lower order mask. Okay, you can easily design. If you know the procedure, if you know, and the select line, if you want to put, where you will put the select lines, for that you have to check the truth table. Accordingly, you will put the, you have to put the select lines. Okay, so these are about the all the mask, and I'm not going to discuss the 16 to 1 and 32 to 1 mask. This is the higher order mask. If you know the procedure how to design the higher order mask using the lower order mask, you can easily design. Okay, next class I will discuss about the how can you design the other circuit. If any functions give, if any boolean functions are there, okay, how can you design using the multiplexer? Rather using the basic gate, you can use the multiplexer for designing any kind of the boolean function. Okay, that we will discuss next class, and followed by the demultiplexer, working principle of the demultiplexer. Thank you, and please like, share and subscribe my channel.